with other, different blocks can interact with each other. Here we have focus on data, and that data you can get from your experiment. If you have some mechanism, you do some experiment and gather some data, and this is a step 0. I told this is a step 0. It's this activity is not appropriate for this talk. Okay, we assume that we have a data set. Either you experiment it and get data by yourself and declare that this is efficient data and post on public platform so that other can get benefit from that data. Another is publicly available data. You can find lots of platforms. I told in my last lecture, lots of platforms are there where you can find publicly available data set. And if you are not able to find data set, then you go some existing research work over blockchain, or what kind of work you want to do, and find out some recent works, recent existing works, and in that work may mention about the data sets with links, and you may get that data set from that link. And this is a step 0. You have to find out a data set. Okay, and we are not talking about the core blockchain research. We are going for data science, how we can use on this. Now the first step here, as we have discussed, we have to download a private public data set. And suppose our research interest at particular on this lecture, I restrict our interest to find out a data set to detect anomaly. Lots of things are there, but here we have a particular thing so that we can perform some hand-ons on this. Now we are going to find out, we are going to detect anomalies inside blockchain. Okay, the first step, we have to find out data set. Now I searched and I found that this data set is publicly available. The link is there. And then after we decide that the efficiency of this data set. This is my first step, as I explained. Now you have to do a statistical test if you want. Then 3 assumptions are there. First, independence of observation. We have learned this thing in my previous lecture. Kindly go through that lecture. Homogeneity of variance. This takes a lot of mathematical knowledge. If you have, then you can do something here. In point 1, independence of observation. It's related to your experiment. If it's not independent, if they are dependent experiment, then it's not useful. It's not fruitful for your prediction algorithm. And for overcome of this, you simply you do some different kind of experiment and find out the things. And then is there any questions? Someone raise hand. Okay. If any question, kindly ask. And homogeneity of variance, you need a lots of mathematical calculation knowledge here. Then after you can do something. And the third one, normality of data. These 3 assumptions must be there to perform a statistical test. Now, these handouts, this lecture is explain this normality of data. Because after downloading this data set, I found that this data set is not normally distributed. It's skewed. And this is the first step. And the second step, we have to perform some data science operations that we call black box. We don't know. We have to discover this. We have to unveil this step in step 2. And as I told you, this data set, if I run this code, then we find that This is zero means this is a malicious. Zero means not malicious, sorry, and this is one is malicious. Okay, this is the imbalanced data set. It means the normality is not there. Then in this step, we perform data transformation. In transformation, since we want to unveil the balancing thing of this data set, then we go for data balancing. We have a lots of mechanisms, as I explained in my last series. We have lots of mechanism to do data transformation. Since we want to know in this lecture related to normality of data, that's why I go for data balancing. And if we search for data balancing, then we have a lots of predefined libraries that can balance your data. Balance your data means they synthesize they synthesize your data. Suppose you have 1326 malicious links, then it's synthesized simply this much of 3 crore, approx 3 crores data. And now it say that this is balanced. And we have a lots of data balancing mechanism. One is SMOTE and another is ADA, saying it's adaptive, synthetic, and others are also there. It means these two mechanisms are there. We can apply on our data set to balance it. And step 3, we have to perform some AI machine learning algorithms to generate different results so that we can compare it. Yes, any question? Please ask. Okay. Now, after applying this machine learning, we have to find out the performance of it. And for that, I explained confusion matrix and AUROC curve. It's very good. And the output of this step, the first step output is a data set. Second step output is to find out what kind of data science, data analytics, or data transformation you want to do on your data set. That we found as an output. This is called, we may define this as a kind of output that we want to work on the normality of data. This is imbalance of data. We want to balance it, and then after we want to perform some machine learning algorithms in step 3 so that we can find that what kind of prediction is there for this kind of data set. If we see that the output of this step 3, you can apply isolation forest. The accuracy of this is 96% for balance data set using SMOTE. If it's not balanced, then the accuracy is 79%. You can use another PCA and another mechanism are used. And this is the output of these steps. And this is the paper 1. It's the existing paper. I have in reference of this paper, paper number 1. And this is the output of this step. See the revealing of one kind of black box, it gets one research here. And another, and this paper 1, it's used SMOTE. And the another one, it used different machine learning algorithms like random forest, decision tree, naive bias, k nearest neighbor, and it's used as a stack of the algorithms, and then after perform on this data set and get the accuracy 97%, AURC curve 99%. All technical terms we have studied in the previous lecture. Now we can see that these are the steps in which anyone can get some kind of output. It's related to your research paper or your research project. Now we are going to explore all steps 1, 2, 3, one by one, so that we can do, or first of all, how they can do these things. We will understand. First step, Step 1 is handouts. Handout, find a data set. Okay, this is first step. And now it's a core topic. If you want to detect some attacks or you want to work on some attack, then you have a lots of research area like account based, anomaly pair, or transaction based, smart contract based, system based, consensus based. These are the core things of your blockchain related to security. You may select any of them. Suppose in this lecture, we suppose malicious transaction, and we are going to find over the net that is there any data set available, because we cannot at this point of time I was not able to generate my data set. That's why I go for public data set. And if we search the data set related to blockchain, then we can find that public blockchain database in GitHub. These are the steps. Okay, anyone can do. Since you talk, the participant asked about blockchain, I am searching on blockchain, and I myself try to get output that whether using these steps can I get any output or not. Now see the steps whether we will reach or not. First, we find public data set. Now if you go in this link, then you can find a GitHub link, and here you have some code. It's random. It's not a thing that I search this thing due to I know that the code is available. No, I did not know about these things, but I want to do some data science on blockchain. That's why I search in step 1 correlated to step 1 the data set, and now we found that some code is also, this is fortunately we found that this code is also available. And then after, if you see that a research publication is also available, it means now the hands-on supporting documents, you have to gather the supporting documents to perform any research. And then you have data set link here, IEEE data pool. It's free of cost. You have to log in and you can download this like this. You have to log in here. After login, you can download this data set. Now you have this data set on your system, but the problem is this: since I do a step by step on my system, so that's why I want to explain every problems what I suffer while performing these research. Now we found that the format of this data set is different. It's a .gh and it's not running in on my Windows system. Then for extracting this, you simply open your command prompt, run as administrator, and type this code. It will extract your data set like this. When I downloaded data set, initially it was this format, GH file, and now after extracting, I got DG out data set. Now you can see it's this much of KB is there. And after getting this data set, now the second work to run the code, because we have code also, and we have downloaded code here. This is the folder on my system, blockchain anomaly detection master. If you go inside, then you can find this much of folders are there. And in the notebooks, you can find Python code here. Okay. Now you can find a Python code. If you will not able to find Python code, then don't worry about this thing. Like PC, K-mean, iForest, all are well-defined machine learning algorithm. And you can find code online everywhere. And then after, you simply run these codes on your Jupyter notebook or Jupyter. And this hand-ons, we want to try run this PC notebook so that I can show you what kind of errors may come. because this is publicly available. It may have some dependency or some error. Then we have to overcome this error. These are the steps. Now, error 1. While running this PCA notebook, we found that no model name is available on my system. This is common problem for the beginners. If you are beginners, then see, if you find anything like this, no models is available on your system, it means this library is not installed in your Python. Then you simply install it. The command is pip install pyote, and after installing, successfully installing, you have to comment it. And this is a general mistake by students. They did not comment it and again and again running same code. This is not good practice. You have to comment it after installing, because after installing, you can run it in any Jupyter notebook. No need to install it. And then after, if you load your data, because you can find this data set available here. This is also another confusion. Here, I extracted that data set and paste here in this folder, in this notebook folder, so that if I run this PC notebook, then it can find data set here only. Okay, you can change it, you can make a folder, but you have to give that path name here. Here you have to provide path name. Otherwise, if you have data in same folder, then no need to provide path name. Now separate, comma. If you run this command, after removing this error, then you will get your data set here. All columns are there. Okay, data are there. It's a head. It means five rows are displaying. Now the second thing, if you run, then the next error will come here, oversampling training data. If you run this cell, then you find that it gives you no model name I will learn is there. It means, again, I told you, if no model, then you have to install. To install, you may find different commands. You have to search over internet. Suppose this pip install, this command is there, you have to run, then this command, and it will work. It will work, and after that you have to comment it. But after running this, you may get another error. It's related to a function. This code defined a function, oversample minority class, and the function is there. You can see oversample minority class, and here it's saying that some argument errors are there. Okay, and if we find this smote function, smote library, then we can see that this is not required. Due to this line, the error is coming. No need of this fraction n jobs. We simply comment it. After commenting it, and simply define sm equal to smote, and it will work. It will work, and it will run, and it will give all results that the author mentioned in their paper. It means now you have data set on your system. Now you have a bunch of code correlated to this research on your system. Now the third thing you need to find out some related work, okay, to perform your research. If we go anomaly detection in blockchain, because we downloaded the data set related to this research paper. That's why I searched it and I found that some of the related work are there. And this is the paper 1, where isolation for 96% I mentioned, and this is the paper 2. Though this paper 2 has used different data set. Okay, but it's related to fraud detection in Bitcoin transaction. I only explain these things so that you can understand that how we can perform these things on different data set also. Okay, In this data set, they found accuracy is 97%. Now it's a opportunity that you may run, because all codes are there. You have to only combine of these things, make a stack and run on this on your downloaded data set, and then compare the results. It's a kind of research work you can do. You can perform here over blockchain data set. If not, then you can go ahead and check that whether the SMOTE or the existing data balancing mechanism can be do something else, because they are repeating the things. They are only replicating these things to make such kind of big data, such kind of record, so that they can remove the imbalance thing. And the internal things, it's like of k-mean. They find some algorithms are there. You can study it. You can study the existing library. But here, if you use your skill, then we can develop another kind of co-balancing technique. Like we saw that, okay, this malicious link is 1000, this one, and this is non-malicious. To balance it, we may divide into different data sets, though the data set is small. Now it's another issue we can solve in our another idea. But here, we simply divide the data set into this 1326 chunks of this zero non-malicious data. It means the zero, suppose it's a start from 0 to this, it's for data set 1, split data set 1. And after that, 1, 3, 2, 5, after this index, you generate another split data set. It's a start from 1326 indexing to 2651. And like that, you will go up to 22,000. See, lots of data sets are generated here. Okay. But it's give you another kind of idea, another kind of research. But these malicious links are same, because it has only 0 to 1325 records. These are same, but we divided into this different chunks. And what we do for each chunks, we have to shuffle it. Shuffle it after adding your this A for anomaly. In this case, okay, we have to add this both records must be added, union of this, and then after we have to shuffle it to perform our next operation. And next operation means now we have data set, a balanced data set. Now we have to perform some machine learning. To perform machine learning, we know that we must have some kind of split data set for training and for testing. Now, suppose we perform 80-20 ratio for this work, 80 for training, 20 for testing. After doing these things, we can evaluate this. Suppose this paper 1, existing method SMOTE, and this is our, of course. And here we use isolation forest, and then evaluation, then accuracy is this. And here we can see that in our proposed data balancing, okay, we use the algorithm KNN, machine learning algorithm, and then we evaluate, and we found that accuracy is 99.0%. Though again, I am mentioning that this is another paper, this is our paper. I am going to submit it very soon. But since I want to explain my idea to all of you, that's why I put here. And this paper apply our proposed data balancing and use KNN algorithm, and then after we evaluate it using confusion matrix, as we have discussed. And the data set is here, this data set, NB15 data set is there. And the paper 3, it used random forest and support vector machine, and then in this we have to compare the results. If you use this random forest on our proposed method, then you can get 99.63% accuracy, and SBM will give 99.38% accuracy. But after that, you can compare, because we have learned a lots of things in confusion matrix like false positive, false negative, all things you have to compare. And that's why we wrote a paper, robust network anomaly detection with k nearest neighbor enhanced. Okay, this is paper 3, and this is a comparative analysis for these two algorithms. The reference is by mistakenly it's a 3, this is 3, and this is 4. Okay, and if you see, we have studied this paper 1, the accuracy is 96, though it used another mechanism is also there. You can see in this paper in reference 1, you can see it's very good. It's a MS thesis for beginner. It's a very good paper. You can see a lots of machine learning algorithms are there, and they have evaluated that separately, and then they compare. Suppose I wrote here this one, and the accuracy is 96%. And the second paper, paper 2, it's a stack of algorithms, and then they apply in this existing method, this data balancing library, Dasin. And using this, it gets 97%, and using this SMOT, it gets 96, and the our mechanism, you can use it. Anyone can use this kind of splitting, or you may modify it. I told you, this is the black box. I want to reveal the things. Then what you want to do, it's your step. You do some modification and do this step. This is simple step. You choose appropriate machine learning algorithms, and then find out the accuracy using confusion matrix or all or other evaluation matrix according to your data set, supervised or unsupervised, as we learn. And then after finding the accuracy, you compare, or you may perform different kind of research over this. In this way, you can perform research on blockchain. Not even blockchain, you can go for any field. But remember, if you want to do data science, then always keep a data set, because without data set you cannot do. Before data set you have core research, and after data set, machine learning. If you want to do something in machine learning, then you go for machine learning or AI course. Okay, but in this lecture, since we focus on data science, then data science is almost like this. And these things I want to explain all of you. Thank you very much. And if you have any confusion, any error in your research while doing these steps, you can message me, you can mail me, you can WhatsApp me. I will be available for all of you. I will try my best to available all of you. Thank you all. Any question? Kindly ask. Yes, tell me. Hello, Professor Thangraj. I'm not able to hear any of you.
If you have any questions, please ask participants. Tangaraj sir, I think.
There is no question.
Yes, sir. They clearly understood
Yeah.
everything. I think.
Yeah.
Yes, sir.
Okay, ma'am. Let us proceed to the next this thing. So, thank you very much, sir, Dr. Sumit Kumar Tetrawe,
Thank you.
for your wonderful presentation on data science over blockchain with the hands-on. And now I would like to invite the Honorary Secretary to propose vote of thanks.
Thank you, sir. Am I audible, sir?
Yes, ma'am. Yes.
Most respected chief guest and keynote speaker, Dr. Sumit Kumar Tetrave, respected chairman, sir, respected fellow members, state members, members from local center, students from various organizations. Good evening to all. It's my great pleasure to propose vote of thanks in this great occasion. Engineers Talk, a weekly online lecture series. The number 7, the series number is 7 on the topic data science over blockchain with hands-on. We are proudly say the Institution of Engineers India Salem Local Center is excited to celebrate its 30th anniversary milestone. On behalf of everyone, I am very much happy to thank our chief guest and keynote speaker, Dr. Sumit Kumar Titrave, as Assistant Professor, Grade 2, School of Computer Application, Kalinga Institute of Industrial Technology, Bhubaneswar, Odisha, on the topic data science over the blockchain with hands-on, for his wonderful presentation and spent his valuable time and the useful insight provided for us, spent his valuable time for preparing the wonderful presentation. Thank you so much, sir.
Thank you.
Thank you, sir. I express my heartfelt gratitude to our chairman, sir, respected chairman, sir, Dr. K. Tangaraj, for his dedication and the passion towards the organizing like this great event. Also, he has always been supportive of good initiatives and encouraged us to strive for excellence. My sincere thanks to Engineers Talk team, Dr. A. Kumaravel sir, Dr. R. Satish Kumar sir, Engineer K. S. Elvam sir for their timely support always. I would like to thank Engineer N. Arumugam sir for his support throughout the event and for his organizing the event very successful. I extend my thanks to Mr. Thiago for the taking care of all the works to organize the programs. Finally, I would like to thank all of you are present here for making the time to be with us today and helping us make this event a very grand success. Thank you, one and all. Thank you, sir. Thank you, Chairman, sir. Thank you, Sumit Kumar, sir.
Thank you. Thank you, ma'am.
Thanks to Arumugam, sir.